Hi there. Okay, today we are going to continue our lecture on the topic of VAR. VAR stands for Vector Autoregression Model. Why we need to use VAR? In this stage, we have to estimate VAR model in terms to find the optimal lag length. The optimal lag length for the step Johansen-Jusselius, error correction term, error correction model, and also Granger causality in vector error correction framework. Therefore, this stage is very vital. We have to use VAR in order to find the optimal lag length by comparing the minimum lag length in the modeling. Okay, so now let's continue about the test. Okay, what we have to compare in this stage is we have to compare the value of a PEQ generated by the VAR. For example, in this case, we use the yearly data from 1975 until 2006. And in overall, we have 42 observations. Okay, to start VAR, we have to open the data by group. We have also must understand because of we use the yearly data, so the lag for the modeling cannot be too long. Maybe for this observation, 42 observation, maybe the longest lag length you can go is 9. So let's open the data by group. We starting, click on GDP, control, REER and FDI, right click, open as VAR. Here, make sure you click on unrestricted VAR. Then the suggestion lag here is 2. Okay, so the equation is here is according to which variable you clicking first. Then you click OK. Here, as I mentioned earlier, the lag suggestion is 2. Alright, so this is the result for VAR with lag 2. And then for comparing, I suggest you to transfer the result into a Word document. So, how to compare? Right, in order to compare, you have to start again and change anti-lag. You change the lag until you find a near singular metric. Right, but here, when you go to lag structure, you go to lag length criteria, click here, you can change until you find the appropriate lag length for the VAR. But here, if you try 10, for example, so log of non-positive number. Okay, so you have to click start again, go to view, and click at lag structure. You have to go to view and click at lag structure and click at lag length. Change 10 to 9. Alright, from this result, it shows that you cannot go further than lag 9. If you click at lag 10, so it must be error occur, so you cannot get the result. So in this case, the longest lag with the 42 observation that you can go is only until lag 9. So for your own data, for your own study, you have to try and error like this to see how far your lag can go. In this case, if you choose to refer to a PEQ information criteria as your preferred criteria, In here, as you can see at leg 9, you can see the star here, meaning that star here indicate as the optimal leg length if we follow a PEQ criteria. If you follow SC criteria, the optimal leg length is 1. LR is a sequential modified LR. The suggestion optimum leg is 7. But my suggestion, you better follow a PEQ. The longest leg is much better in order to developing the modeling in the dynamic modeling. Alright, so according to result here, my suggestion follow a PEQ because the longest, as I stated earlier, the longest leg is much better in order to develop your dynamic model. So let's estimate again your var. As I said here, we start with 2 and the longest var you can go is only at 9. So you must keep changing the result here. Change to 3, then you said okay. So copy this result again, go to Word. So from there you can analyze. Which number you have to compare is this number. This number. You have to compare and you have to report this number and select the minimum one. The minimum PEQ is the best result. Okay, so you have to report this number. Please refer to the module how to report the result of a PEQ from var. Okay, so again you have to repeat this process again. Go to estimate, change to 4. Alright, so you will get another result of var and report the value of a PEQ here. So that's all. For example, just now this is two-way. I mean there is two way in order to find the appropriate leg length from var. The first one is by comparing the value of a PEQ number, but you have to run the estimation from 2 until 9. But there is another way. You have to click at view and go to leg structure, then you click at leg length criteria. Click 9 because 9 is the longest leg you can go. If you click if you use leg 10, the system cannot write for you because your data is not long enough, only 42 observation. So the far leg you can go is only 9, so you click OK. According to result here, it shows that the optimal leg length suggested by AIC is at leg 9, and this is one way. The other way is you have to estimate one by one from leg 2 until leg 9 and comparing the value of var. By comparing the value of var, when you see at the value of a PEQ at the bottom of the var result over here. Okay, so there is two ways. You have to know both idea of this. Then for example, if your optimal leg length is 9, so you can go to estimate. Okay, if your optimal leg length is 9, so you can use leg 9 to run your Johansson-Jusselius in the next model. So until now, for this video, we will continue in another video of Johansson-Jusselius co-integration test. Okay, thank you.